the question. Okay, we have read the question. Apa dia nak cari sebenarnya ni? Apa nak buat sebenarnya? Apa nak buat? Cepat-cepat saya nak semua orang participate sebab saya takkan buat soalan ni seorang-seorang. I don't have the answer pun. I want we want how to, if you get like this kind of question, how to start. What the first thing you want to start? What the question ask for? Apa dia question suruh buat ni? Anybody cepat? Kita ada banyak, tak ada banyak masa, tak ada 1 jam je. Yes, you want to calculate the top, okay? Because the first is the first column, you want to macam to fill in all this table. First, you want to calculate the top. So how to calculate the top? The motor torque kan? How to calculate this motor torque? TE equal to TL. Okay, and you have the equation of TL. Let's say kita ambil 0.0016. X ni kata 0 omega m squared. Okay, saya nak tanya. If the motor torque is already given in table 1, what's the use of gear ratio and efficiency tu? In the question, on the first paragraph of the question. Kalau you tak jawab, kita wasting time. Okay, we need to discuss. You should use this time to ask me if you don't understand anything in the question. Tanya sekarang. Saya takkan buat semua ni. Kalau kita terlepas tak sempat discuss sampai C, nanti you rugi. What's the use of gear ratio? Tak ada orang ke? Hello? Jawab. Selalunya kita guna gear ratio, apa kegunaan gear ratio if given in the question? You're wasting your time lah.
Load speed.
Untuk speed apa? Apa relationship dia?
Omega M.
Omega L over omega M kan? This is your gear ratio. Okay? But in this case, cuba tengok on the question paper, omega L is already given to you and the motor speed also already given to you, which is at peak hour, off peak hours and unusual instance. So untuk A ni is redundant and you don't have to use it for this question. But if in any other question, if A is given and only the compressor speed or the load speed is given, so you must use the gear ratio to find the motor speed. Because this is the relation of the motor speed and the load speed. Boleh ke?
Boleh.
Okay, so next. Apa nak buat? So this omega M is this, which speed you want to use this one? You want to calculate for the torque. Speed mana yang nak guna?
Rated.
Rated. Okay. So TE, sorry. TE equal to TL equal to 0.0016. Katalah 0 ID kan. So 2850 times 2 pi over 60 squared. Betul ke macam ni? This one at rated. But cuba baca soalan. Dia punya soalan, the motor was chosen such that at rated motor frequency and rated voltage, the motor operates the compressor at 27x0 RPM. Dia tak cakap pun the motor operates the compressor at rated speed. Kau nampak tak? So kalau macam ni, betul ke salah ni? Ini you ambil at rated speed. Omega M rated. Tapi at rated frequency and rated voltage, the speed of the motor is not at rated speed, but the operation is at 27x0 RPM. So question tu nanti lebih kurang macam ni you have to think. Bukan this question lah, tapi you will have such macam question ni, you have to think. It's not a straightforward question. And it's 40 marks. Tak faham, better tanya. So this is the induction motor. Okay, now katalah at rated, so kita buat at F rated. Berapa F rated dia ni? Berapa V rated? F rated berapa?
F rated 50 Hz.
50. V?
400 bahagi setri.
400 dulu. V rated dulu, tak apa, VT dulu. Bukan V phase, VT VT rated. Okay, so at this rated, this is the induction motor. Kemudian kita ada load characteristic like this. Dia macam dia omega squared kan. So TL macam tu. So lebih kurang kat sini. So tak apalah, tersalah sikit, tak apa. This is at TE, and from the rated kita nak cari TE, and this speed. Kita nak tahu this speed. Is it 2850 or 27x0? Sebab the information
27x0.
Sebab the information given that at frequency the motor drive the compressor, maknanya the steady state ni, this steady state point at rated frequency and rated voltage, the compressor speed is 27x0. Okay, RPM. And from here baru you can calculate for the TE. So TE ni kita boleh kata bukan TE rated, this is TA design. Okay, kita namakan dah design, this is NM design. Okay, so ini salah. If you do like this, you take the rated speed, it's not correct. So kena ambil at design. Okay, baru you kata TE equal to TL equal to 0.0016 times 27x0 times 2 pi over 60 omega squared. Okay. Okay, this is at, kita kata at design condition. Selalunya kita ambil at rated condition, but this operation is at another speed, so this is at design operation. Are you okay? Nanti you akan calculate lah, dapat the value. Okay, based on your ID. So kita dah start buat this one ke? Belum kan? Not yet. This is at design condition or at previous condition baru. So next, apa yang kita nak buat? You want to calculate the motor torque. So let's say we want to calculate at peak hours. We want to calculate the motor torque at peak hours. What should we do? At peak hours ni, the motor speed dia greater than the design speed or less than the design speed? And orang lain mana? Okay, kejap. The design speed is 27x0. This one 2850. Is it higher or lower?
Higher.
Higher kan? So the speed, maybe the speed is somewhere here. Speed is somewhere here. So we must move. Ini pun dah tersalah, tak apalah. Okay, we must move your induction motor to the right. Ingat lagi tak? Kita akan move to the right. So, lebih kurang macam tu. Okay. So, this is at peak hour. And this is a new speed which is 2850 RPM. So, you will have a new torque. Okay. So, how to calculate this new torque? First, you tengok N for peak hours. Is it greater or less? It's greater than NM design, right? So, which control strategy you want to use?
V over F.
So, if more, so V, constant V over F, control strategy. Yeah. Now, for V over F, the frequency should should be higher than the rated frequency or lower? V over F. Higher. Okay, F should be higher than F rated. What about V terminal? Same. Is it equal to the rated terminal voltage? Okay. K V T rated. Okay. Macam tu. So this is for peak hours. So you kena tengok for different condition, peak hours, off-peak hours, unusual instant. So you will have different control strategy, and that one will be used to calculate for your terminal voltage nanti. Alright. So apa nak buat? Next. How to calculate K for this V over F? F new over
F rated.
F rated. So, which formula you want to use to calculate your new torque? TE new. TE ni tak directed dah. TE at design equal to NSL new over NSL at the design ya, yang kita dapat tu. Okay. Okay, this is formula to get This is a formula to get for your torque. You want to calculate for your torque, but before you calculate for new torque, you have to find your slip speed. The NSL new ni. How to get your NSL new ni? First, you have to calculate for F new. Okay, F new ni macam mana dapat? Kena ada NSL new. How to get your NSL new ni? NS dah calculate ke belum?
Belum.
How to calculate your NS ni?
120 frequency over pole.
Frekuensi berapa? 50. Pole berapa?
50.
So NS berapa? Berapa NS?
3000.
3000 RPM. So, macam mana dah dapat NS, baru kita dapat TE new. Alright. So, this is how to get your TE new. Basically, you will repeating the same procedure for peak hour, off-peak hour and unusual instant. But you must know whether it is apa tu? Sama ada V over F control ataupun varying frequency control. Kalau frequency control pula macam mana? For less than varying frequency, constant voltage, F will be greater than F rated, VT new equal to VT rated. Okay, this one VT. Kita tak buat lagi phase ke apa. This one VT for the induction motor. Okay, then you repeating the same procedure to calculate for the motor torque and the motor terminal voltage applied. Boleh macam ni? Okay, this is how you will attempt the question. First read the question and then try to kena show all the calculation. For peak hours, satu lagi please label your calculation. Katakan you nak first calculate, okay, calculation for peak hours. Buat. Lepas tu second one calculation for off peak hours. You must write down what you are doing. Kalau just tulis je, maybe some marks will be deducted. Yeah. So 3 times you have to repeat the same procedure to calculate for the motor torque and the motor terminal voltage and also for the motor frequency. Any question?
Madam,
Yes.
untuk yang peak hours tadi kan, yang tu guna variable frequency kan? Variable frequency.
Betul. Ini salah kan, kita belum tengok lagi kan? Okey, tengok kat sini Okey, tadi sebab tu dah kita kena discuss. Okey. Tadi kita belum kita patut compare dengan yang mana? And hours ni 2850. Peak hours. Okey. Kita patut compare dengan
NM design tu kan.
NM design kan? So
Betul.
NM design tu NM design ke? Siapa tanya soalan lagi? Kita patut compare dengan NM design ke dengan yang mana?
NM design.
NM design kita berapa?
27X.
Ada 7.
03.
Okay, so dia greater than the 2700 katakanlah kan. So NM ni dia greater than the design. Kalau greater guna V over F ke variable frequency?
Variable frequency with constant voltage.
Variable frequency with constant voltage kan? So guna yang nombor 2 ni. Ya. Greater. Alright, this one for an operation greater than an design. Okay. So repeat yang ni lah. So kena tahu dua. Kita ada 1, 2, this 1 and 2. So kena tengok dulu. Okay, if greater than n design, so you guna variable frequency constant voltage. So VT equal to VT rated. Ini belum ada V phase lagi dia tak suruh calculate untuk V phase lagi sebab in the table you have to put the terminal voltage. So you don't have to change by dividing by √3 ke apa, not yet. Boleh tak sampai sini?
Boleh
The
doktor.
most important thing nak faham soalan. Then you akan repeat the same formula. You akan analyse whether it is higher or lower than the design speed, or kalau ada soalan lain than the rated speed. In this case, the rated speed is not equal to the design speed. You compare and you have to choose whether you nak guna the constant V over F or varying frequency. Okay, then you fit in all this information in the table. Alright. So can we move on to part B? Ada soalan lagi tak? So A ni, the gear ratio, if the speed of the motor is not given, so you must use the gear ratio to calculate the speed of the motor, okay, based on the speed of the load. Okay. In this case, dia dah bagi, so redundant information. Maybe in another question, dia bagi A, but dia tak bagi motor speed, you have to also calculate for the motor speed. Alright, ada apa-apa lagi yang information yang you tak faham kat atas ni? Tak ada dah kan? Okay, so next, can we move to part B? Boleh eh? So now, the question asks you to verify that the motor can provide sufficient power to drive the compressor during the unusual instant operation. Mana satu unusual instant operation? Mana satu? Part B. So during unusual instance, sufficient or not the power to drive the motor? Okay. Dia kena buat sikit comparison. Jangan jawab je sufficient ke tak. Kena ada why. Kena ada kenapa ia sufficient or not. Okay, so P motor sekarang berapa? At this instant, dia cakap, okay. Kalau look at the question, dia kata, based on the motor data sheet, the motor is able to provide additional 20% of the rated output power for a maximum duration of 15 minutes before causing motor damage. So the maximum motor power will be 1.2 daripada P out rated is 20% ya. So berapa rated P out sekarang? 1.2 from 55 kilowatt. Okay. So this is your macam maximum of power for the duration of 15 minutes only. You can achieve before the motor get damaged. Okay. So now, how to calculate P out? Is this the value yang should we use? 50k ni? Is it the correct value? Mana ni? Involve lah, take part sikit. Saya tanya soalan. Tidur semua ke? Macam mana nak buat? Mana orang lain ni? Zayani? Atira? Zayani?
Ya,
Apa? Macam mana ni nak buat?
untuk kira P motor tu mana?
Apa formula yang kita guna yang relate P motor and the speed? Selalunya, formula apa kita guna?
TE omega M.
Okay. So, we already calculated TE dekat jadual tadi kan? Kita pun dah ada omega M at the unusual condition. So, P out at unusual time equal to TE unusual. Kena ambil yang dekat kita dah calculate tu times omega M. Omega M mana? What's the value?
3,100.
Ya, 3,100 tu you have to convert convert dulu.
Over 60.
Okay. So nanti akan dapat TE unusual times 3,100 2 pi over 60. Okay, you akan dapat your value of T out. So you compare dengan your rated ni, this value, you compare. So you can answer whether it can provide sufficient power to drive the compressor or not. Okay, so P out yang unusual, you compare dengan P out rated. Baru you can put the answer. Okay, whether it's sufficient or not. Boleh sini. So basically part B ni, you already have all the information in part A. Okay, you already have all the information in part A. So you just use the formula that relate the output and the torque and speed to verify your answer. Okay. Boleh? Yang banyak makannya part A. Okay, now what about part C? That's why this question, the combination of induction motor and synchronous motor. For part A and B, that is your application for the induction motor. For part C ni, if you read the question, dia kata, before I'm going to part C, do you have any more question on part A? Ada apa-apa yang tak faham tak kat sini? Any question? Tak ada soalan? Pandai dah ya, bagus. Tak ada soalan ya? So part C, after several years of operations, the motor is replaced by 55 kilowatt, 3-phase 400 volt, 50 Hz, 2-pole 0.8 power factor leading Y connected synchronous motor with a synchronous reactance of 5 ohm and rated field current of 10 ampere. Determine the motor armature current and power factor when operating under the unusual operation with rated field current applied. Okay, so apa dia nak cari ni?
Armature current and power factor.
Dia nak cari armature current which is IA. So because this is 3-phase, IA must have angle. Kat sini ya. Bukan magnitude saja, IA must have angle, magnitude and angle. Okay, you want to find IA. So it is synchronous motor. Which formula you want to use to find your IA? Ingat lagi tak? Macam mana synchronous motor punya equivalent circuit per phase? You ada RA, you ada XS. Okay, so you have IA here. And this is B phase. EA. So what's equation you want to use in order to find your IA? Anybody? Nah, cepat. Wafi? Alia mana? Equation apa nak guna? Yeah?
EA equals to V phase plus IARA.
Yes, okay. KVL around the loop, EA equal to V phase plus IA RA plus JXS. Okay, what's the value of RA in this case? Ada any information?
Tak ada.
Tak ada, so your RA is equal to 0. Rearranging this formula, you will get IA equal to V phase minus EA over JXS. Okay, ini kat mana ni? Dia kata under the when operating under the unusual operation. So kalau unusual operation, kita boleh refer to the speed lah. Okay, it is, you want to calculate IA at unusual operation. Okay, what is the speed at unusual operation ni?
3100.
Nm equal to 3100 RPM. So what is the rated speed for this motor? For this synchronous motor, what is the rated speed? Sebab kita nak compare which nanti kita nak guna yang mana satu? Ada constant V over F ataupun varying frequency with constant voltage. So we must compare our operation speed dengan rated speed. But what is the rated speed for this synchronous motor? Alia? Tak ada. Yusof? Apa formula nak cari speed for the synchronous motor? Synchronous motor macam mana graf dia? Apa speed dia? Ni sama je, dia ada number of pole, frekuensi semua, kan?
Betul.
Macam mana?
100, yang guna 120 tu.
Mana 120? Mana 120? The rated speed for synchronous motor 120 lah. 120 frekuensi
Frekuensi
over
pole.
pole. Synchronous motor dia straight line je macam tu. Synchronous speed dengan the motor speed rated sama. Ingat lagi tak ni? Tak ingat? Next week dah test lah. Over 2. Berapa dapat ni? 3,000. Okay, 3,000 RPM. So now the operational speed is greater than Nm rated. Jadi you nak kena guna apa? You nak kena guna apa? Constant V over F ataupun variable frequency?
Variable frequency.
Variable frequency with constant voltage, ya. So kalau you guna variable frequency with constant voltage, macam mana? Okay, tak apalah macam ni. So this operational speed is greater than the rated speed. Okay, katakanlah ya. Okay, katakanlah you ada operation speed now is equal to 3,000 RPM. Which is equal to your rated speed. You nak guna which type of control strategy? Which one? Is it constant V? Is it lower than the base speed or higher than the base speed? Ni penting ni sebab it is based on your ID. Tiba-tiba you put your ID, your operational speed is equal to your rated speed. So which control strategy you want to use? Is it variable frequency, constant voltage or constant V over F? Tiba-tiba Nm ni equal to M rated. Nm rated. Okay, kalau ini kita consider Nm is greater or equal to Nm rated. So in this case nanti F pun akan, your F new pun akan equal to F rated tau. So you guna variable frequency, constant voltage for above the rated speed. Boleh? Boleh ke?
Ulang balik pada macam ni.
Okay, macam ni. Nanti, because this letter it based on your ID, sometimes you akan selalu kata Nm rated, Nm greater than Nm rated. You akan guna variable frequency, constant voltage kan? Okay. Kalau Nm is less than Mm rated, you akan guna constant V over F control. Betul tak macam ni? Betul. Sekarang kalau Nm tu is equal to Nm rated, you nak pergi mana? Okay, if Nm equal to Mm rated, you akan guna this strategy. Sebab kita akan guna Nm is greater or equal to Nm rated, you will use variable frequency, constant voltage. Faham tak? This one. Okay, you akan guna variable frequency with constant voltage strategy. Where F nanti you akan dapat F equal to F rated and VT equal to VT rated. Okay. Sebab this is based on your ID. Sometimes dia akan jadi macam tu. Okay. Dia akan dapat rated value balik. Boleh? Ini important ya. So this part, tadi kita proceed balik. Kita tengok nak calculate for IA. We want to calculate IA for unusual instance. So if higher than the rated speed, you want to use V phase. In this case, how to calculate your V phase? Berapa V phase? V phase macam mana? Equal to, because it's Y connected, right? Y connected synchronous motor, V phase will be equal to V terminal over √3.
3.
Yes. Sebab dia Y connected. Because we want to do calculation per phase, yeah, based on this equivalent diagram. Kalau delta connected, V phase equal to VT. Ini yang akan masukkan ke sini nanti. To calculate for your V phase. What about your XS? How to calculate your XS new? It will be new formula. So, kena cari K, XS.
S.
Okay, now, how to calculate your EA pula? EA. Is it? Ini kita nak calculate EA at new condition, right? How to calculate your EA? Kalau nak calculate EA new, macam mana? EA new will be equal to, this only the magnitude. Magnitude of EA new will be equal to K flux omega M new. Alright. So this is at new condition. Where is your new condition? One is an unusual instance. So what is your omega M new ni?
3100.
3100 pi over 60. Yes, betul. How to get your K flux pula? What is your K flux? So in this case, K flux dia kata determine the motor when the unusual operation with rated field current applied. So if with rated field current applied, K flux will be equal to K flux rated. Boleh? Because it's operate at rated field current. So, katakanlah soalan cakap pula, in this case, refer to the question. If the question said that the unusual operation with rated frequency of rated field current of 70%, ataupun dia kata unusual operation at 70% rated field current. Itu pula macam mana? If it said it operate at 70% of rated field current. So now what will be your K flux? What will be your K flux new ni?
Darab 0.7.
Jadi 0.7 K flux rated. Macam tu ya. So you must read the information. Because the question, kalau you tengok sekaligus, you takkan, it's not a straightforward kind of question. Okay, because kalau kita tengok K flux ni, dia akan proportionally related to your flux and also IF. Okay, so kalau it's 70% from your IF, it will be 0.7% of your 0.7 of your K rated lah. K flux rated. Boleh ke? How to calculate your K flux rated ni? Ini kalau you ada IF, nak calculate IF new, the relationship is IF rated equal to K flux rated. Okay, this is your relationship. Ini kita pun dah pernah buat juga. Now, so to calculate your K flux rated, nak tahu yang at new condition, so you must calculate at rated condition, your K flux equal to EA rated over omega M rated. So this only given the magnitude, okay, omega M rated. Apa nak cari tadi? Cari IA. Okay. For synchronous motor, this only will give the EA, the magnitude of EA only. For synchronous motor, you should have the angle of EA. Kita dah belajar macam nak cari angle of EA, angle of EA new. Macam mana hari tu? How to calculate EA of angle of EA new? Kita kena cari EA ni sebab apa? Sebab kita nak letak in this equation to get your new IA. Okay. V-phase dah ada, JSS pun you boleh calculate. Now your EA. EA new, how to calculate the angle of EA new? Kita dah buat sebelum ni. Ingat lagi tak del new ni? Is equal to sin inverse sin DE omega M XS. Okay, this formula will be given to you. You only have to rearrange saja nanti. Okay, the magnitude of EA. Okay, how to get your TE ni tadi? TE tadi ambil daripada mana TE ni? Hello, TE ni nak ambil daripada mana?
Unusual motor torque.
So dah kita ambil at unusual. Orang yang tak ada ke? Awak seorang je ke Syazwan? Yang lain tak ada ke? Mana yang lain ni? Okay, omega M ni ambil kat mana? Daripada table juga.
Motor
1000. Okay, motor speed at unusual condition. So XS, where do you get XS?
5 ohm.
No, this one XS new. Ingat tak tadi patutnya kita dah calculate apa tu? Yang frekuensi tadi, frekuensi ada kat sini kan? The new frequency. The new frequency will be here. So you use the formula to calculate for K and the new frequency. V phase? V phase new. So EA is the magnitude yang tadi. Alright. This is how you calculate for the angle. And after you get the angle, you can put into formula so you can calculate for IA. IA must have magnitude and also angle. Okay, now ada apa-apa saya tertinggal tak in this question? 0.8 ni kenapa kita tak guna? Where do you want to use this 0.8?
Power factor.
Ya, power factor. Kita ada guna tak in the calculation? Kita nak guna kat mana 0.8 tu? Ha. .8 tu mana kita nak guna? What we use 0.8 for? Have you calculated your EA rated in this case? Tadi kita just discuss about EA new. This is the flow how to calculate EA new. But in order to find nanti K flux at rated tu, you have to have EA rated. How to calculate your EA rated? Kita belum calculate EA rated. Tak ada orang jawab? Okay, so you nak stop sini ke? I let you go back and think or you want to answer and we can discuss now.
Discuss now.
Saya tanya jawablah. Ha. EA rated, how to calculate EA rated?
Cari IA rated, madam.
Yes. EA rated equal to V phase rated. IA rated JXS. Okay, this is at rated condition. EA rated is important nanti because kita nak calculate K flux rated. Okay, now V phase rated kita dah ada 400 divide by root 3 kan? Your IA rated, how to calculate your IA rated? Sebenarnya this question give all the information, but if you don't know how to use the information, so that's it. Kosong je kertas nanti. Ini kena garang sikit lah. Semua sebelum ni saya je buat. Ini semua diam. Dah last class lah ni. Okay, how to calculate your IA? Information mana yang kita nak guna? Kita ada 50k kilowatt, 3 phase 400 volt, 50 Hz, 2 pole, 0.8 power factor leading, Y connected synchronous motor. How to calculate your IA? IA rated. Apa formula? Formula power. Ingat tak? The power flow. Okay, Assalamualaikum. Kita stop sini 7 minit lagi ni. Power flow. Power. Buka nota revision. Nama dia revision class. Saya takkan bagi semua. Seriously, if you don't know how to do this question, lepas test 3 nanti you akan menyesal. Pernah dapat ni, P in rated equal to apa? Faster. Over
EV phase rated cos
yes,
theta
3V phase rated cos
theta rated.
cos theta rated. Okay, what is this cos theta rated? This is your power factor kan? So power factor mana?
0.8.
Yes, kat sini lah baru 0.8 datang. So we use 0.8. So in this case, what is the value of P in? Kalau kita ada power flow, if you still remember, this is P in. So we are using P in to calculate the I rated ya. This is P out. Yang given in the question, 55k kilowatt tu, is it P out or P in?
P out.
P out rated. So in this case, anything mentioned about the losses?
No, P in equals to P out.
So in this case, P in equal to P out. Unless katalah the efficiency of the motor is given like katalah given the efficiency is 80%. So how to calculate your P in?
0.8 P out.
P out 0.8 P out ke P out over 0.8? P out over the efficiency kan? Macam tu ke?
betul.
So in this case, if there is no anything mentioned about the P out, so you can assume anything, tak ada apa yang mention pasal losses, you can assume it's a lossless punya operation, P in equal to P out. So from here, you can get your IA rated but only the magnitude. Okay, IA rated, so akan dapatlah IA rated but only the magnitude. How to get your angle? Inverse cos 0.8. So akan dapatlah. So from here, put into the formula, you will get your EA rated. From EA rated, you can get your K flux rated. Okay, you akan dapat K flux rated based on the information. So katakanlah at the new operation, it said that the unusual operation, it operate at 70% of the rated field current. So dia akan dapat 0.5 K flux rated lah. So baru akan ada value. So apapun first, you use all the information to calculate EA, IA semua at rated condition. Lepas tu baru you use the information to calculate IA at new condition. Okay? So this is not kind of guided question. Dia tak guide you. Dia tak cakap first find your EA, first find your apa tu new frequency ke new XS. It's not a guided question. Dia punya question, they ask for IA new, but you have to go through all this apa tu formula calculation to get your IA new. Okay. By the way, EA baru, EA new yang kita dapat ni, is it dia ada angle and magnitude and angle kan? So is it the angle is it positive or negative for EA for synchronous motor? Selalunya for synchronous motor, the angle of EA ni positive or negative? Kalau motor. Syazwan?
Negatif.
Okay,
Negative.
Negative. For synchronous motor, it's a negative angle because kita assume dia in motoring mode. Kita tak buat in generating mode, ya. Alright, I think that's all for this question. It's cover question 2 for induction and synchronous motor. For question 1, DC to DC converter kan. So it will be operation or application of DC to DC converter in DC motor. So nanti you kena calculate, let's say kalau you ada in DC motor, how many control strategy do you have? You ada VA control kan? And you ada flux control. Ingat lagi tak ni?
Ingat Mida.
So for flux control, this one you have to calculate for nanti you akan kena calculate for apa orang panggil ni? Del A, del B and also del F. Angle kan? Apa orang panggil? Cepat. Bukan angle. Apalah tu nanti you tengoklah dalam contoh So these two kind of control strategy akan ada for controlling the speed of the DC motor. The application of DC converter for controlling the speed of the DC motor. So you tengok balik all the practice problem that we have done in class and also the video in Brighton. It should be okay. This question straightforward question saja. Yang banyak pusing-pusing is question 2. Okay. Any more question? Oh, dah pukul 11 lah. You ada kelas lagi tak lepas ni? Okay. Dah attendance saya dah letak dekat chat, tolong ni tak ada attendance. Okay, that's all for now. Siapa yang nak jumpa saya tu tunggu sekejap boleh tak? Siapa dah tu? Okay, that's all for now. Thank you very much for attending the class. Today is our last class. I hope all the best in your future. And anything, keep in touch lah dengan saya, ya. Okay, thank you. Assalamualaikum.
Thank you Mida.
Thank you, Doktor.
Okay. Amir ada ke? Amir Iman? Tak ada.
Ya, Doktor.
Okay, bye.
Thank you, Doktor.
Welcome. Mana Amir? Amir tak ada? Okay lah, bye.